Hello everyone, welcome back to the channel. I hope you are doing well and would be practicing and enjoying whatever is taught to you by now. And if you have any doubt regarding the concepts we have covered in the last video, you can drop the comments. I'll respond to everyone. And in today's video, we will be covering the data types and the operators which we commonly use in Python. So let's get started with the video. So let's get started with our today's video. So today we're gonna cover the topics that are the data types, which defines what kind of data you can enter or what's the type of the data that is and so we'll be talking about the data types we commonly use in Python, and I will get you familiar with the type function and how it is used. So basically, we have three. No, I'm sorry. Basically, we have five data types in Python, which are the integer, and secondly, we have the float values, third, the complex numbers, and the booleans, and lastly, the string. So, what's the difference? Integer are those numbers which don't have a decimal point value, like you all know. See, all the whole numbers are the integers, and the number with the decimal value, these are the floats. Real plus imaginary numbers combination is the complex number, and booleans are the true or false, where true corresponds to the value 1 and false corresponds to the value 0 in integer type. And lastly, the strings, which are the text in quotes, like I told you, whatever you write inside the quotes is considered as a string. I'll write even a number like 7 or 8 or whatever. If we write it in the quotes, it's considered as a string only. And to know the type of whatever the data type we have inserted or the user has inserted, if we want to know the type of the data, like if it is an integer or it is a float or a string and whatever, you can use this type function. Like here it is used, it's written type age. So the identifier, it's the age is the identifier in which the value is stored, that is 25, which is an integer. So it will return class int like this. Similarly, the price, which is here, is a float value. So if you write the type of price, it will return a float. I will show you this practically as well. Here, I will show you. I have given the input as num18, or you can also use the input statements like I told you in the last class. Let n be any variable or name that is the identifier, int input, enter a value. Or we can also have any string value, str1, and hello world. And now if I will print the I'm sorry, the type num, similarly, I'll change it to str1 and here. And now we will run this program and see, it's printed. The the data type of num, which is 18. 18 is an integer, so it has printed class int for the type of the num. Similarly, the n identifier, it has the value 9. 9 also is an integer, so it has printed the class int. And lastly, the str, which is the string, so it has printed class string. Same you can try with the booleans. I'll write this and 0, no, true, and print type boolean. I'll comment these out because we have seen the result of these. Control plus backslash. And now I'll run this code. See, the class is bool for true. So you can check whether the number or whether the data that is given, if it is an integer, if it is a float, boolean, or complex number also. I'll show you with the complex number as well. Equals to 7 plus 6j. So now the type of comp. The data type of the comp is complex. So the comp is the comp is containing the value of a complex number. So it has given the output as complex. I hope this is understandable to you. So now you already know what are the data types and how you can identify or how you can know what kind of data type that is inserted by the user. But there are some operations you cannot perform on a particular data type, or there are some operations you want to perform on other kind of data types. So for that, you can also convert the data type which is inserted by the user to the one you want to work with. So for that, we use this type conversion. Uh, you can convert a data type of the given variable by using uh, this operations. Type conversion is also called as typecasting. See here. It is important. You can be asked about the questions in the Viva also. So how you can convert the type of the data? Like if you have an integer and if you want to convert it as a float, you can convert it directly by it's written 20, and if you want that integer c, here a is a is having the value as a string. Since the 20 is written inside the quotes, it's a string. And if you want to convert that string into an integer, you can just write using another variable. You can write int and inside the parenthesis a. So now the data type of a is converted into a integer. A's value is now a 20, not the 20 in the strings, that, not the 20 in the quotes. So now it's an integer. You can perform the addition or any arithmetic operations on a now. And similarly, if you want to convert this any integer into a string, you can just write the str and inside the parenthesis the integer or any variable which is containing the string, which is containing the integer inside it. So now that string, that 100 is now converted to a string, and if you will add value plus c, you get. This operation is called concatenation and it is performed on the strings only, which we will talk about when we will start our concept about the strings, and we'll go deeply in the other functions or operations which you can perform on strings. So for now, it's only this. We will practically show how, like, we'll practically see how type conversions actually works. And see, again, num 18. I have an integer, and I will convert the type of the num to a float. Sorry, float num. And now we'll print the type of num, which type is and see the type of the num two, which is storing the num in a float, is now a float. If you will print num2, sorry, yeah, we'll print num2, it will return. See, it's now num's value is 18, but now we have converted it to a float. So it has an decimal value at the end, that is zero point 0. This is how your interpreter converts the value. Since we are talking about the type conversion, I will let you know that there are two type of type conversions in Python. One, like I showed you, which we did manually. It's called the explicit type conversion. Explicit type conversion. In this type conversion, you explicitly or you manually write the data type in which you want to convert your data. And second one, it is the implicit data type, implicit type conversion. See, what is implicit type conversion? Like, sometimes when you perform some operations, like if you try to add a float value to an integer, your output will always be in a float value. But your one input, it was just an integer, but the second one is float. So the final answer which you have got, it is in the float format. So the type conversion done by the Python interpreter by itself, it's called the implicit type conversion. Like I'll show you. See num1 18 and n2 again 18.0. If I print n1 plus n2, we'll comment this out. Shortcut to comment out in the VS Code is control plus slash, and here the output is 36.0. We didn't like give instruction by ourselves to convert the data type, but the interpreter has automatically by itself has converted the data type into a float. So this type of type conversions is called the implicit type conversion. I hope this is clear to you. There's one more thing to keep in mind, that is, if you try to convert a string which is in a float format to an integer, you cannot directly convert it to an integer. It will give you an error like C 2.6. And if I'll convert the type n2 into a string, sorry, not in string, integer, n1 and print n2, it will give me an error C, invalid literal for integer. So if you want to convert this kind of strings to an integer, first of all you will need to convert this string into a float value. Float. Now it would be converted to a float value. See, 2.6, it's not a string now because it don't have quotes on the outside. And now after converting the n2 into float, you can convert the n2 into an integer. Like int n2. And now we will print this. And now it is converted to an integer. I hope this would be clear to you. And now we will move forward. Now we will start with our new topic, that is the operators. See, first of all, we will cover the arithmetic and comparison operator. So, what are the arithmetic operators? Whatever the mathematical operations you can perform on your integer type value or your float type value, these can be done only through these arithmetic operators. Like whatever addition, subtraction, multiplication, division, and all, these are done with the help of these arithmetic operators. In Python, we have seven arithmetic operators, which are plus, minus, exponent, that asterisk. It is for multiplication, and slash for division. But what about these double slash, this modulo, percentage, and the double asterisk? These helps in this one is a floor division. Like it will perform the division and it will give you the output like the quotient but without any decimal value. And this is the modulus, like whatever will be the reminder you'll get after completing a division, it will return you the reminder. And lastly, the exponent. If you want to calculate the power of any number, the power it is raised to, you can use this exponentiation function. See all these functions practically in our VS Code. Now N1, 23, and 2, let it be 90. And now we will perform all those operations on these two values, like N1 plus N2 and 1 minus N2 and 1 into N2. Now we will print these all out. Print. Now see N1 plus N2, it is 113. N1 minus N2 is minus 67. N1 into N2 is 2070 division. And here the floor division. Why it is given as 0? Because um the remainder, the value before the decimal is only 0. And again, the remainder we have is 23, and this is the exponentiation value. Oh, it is so big. I will change the value of N2 here. And now we will see here. Again, the floor division is 11, the remainder is 1, and the power is 529. So this is how these operators work. And secondly, we will be seeing the comparison operators, which shows the relation between the two, what we say, the two numbers, or yeah, the two numbers. You can use the relation operators only for the numbers, numeric values, not for the strings and any other value. So here we have first equal equal and exclamation equal. So this double equals is used to check whether the numbers we have given or written on which we want to perform the comparison operation, whether these numbers are equal or equal. And secondly, this exclamation equal, which we say as not equals to, it is used to check whether numbers are not equal to each other. Secondly, we have greater than and then smaller than, to check whether which number is greater and which is smaller. And same, greater than equal to, smaller than equal to check whether the numbers are greater plus equal. It will return true if if any of the condition is true. Like if the number is greater, if it's greater, it will return true. But if it's not greater but it's equal, it will also return true. Similarly with the same, this one as well. We will see this also practically. N1 89 N2 99 and N1 equal to N3 and not equal to N2 and N1 greater than N2 N1 smaller than N2 greater than equal to N2 and smaller than equal to N2. And now we will see the output. C. N1 is not equals to N2, which is N1 is equal to N2, which is not true, that is false. N1 is not equal to N2, which is true. And N1 is greater than N2, no, that's false. Similarly, all these, you can see the output of the relation operator is always in a Boolean format, and you can use these outputs to perform your further operations or the questions you want to solve using these operators. Now, moving forward to our another topic, that is assignment and logical operators. What are the assignment operators? See, this equal sign and which is used to assign any value to the variable C. If you want to write this expression or the equation, which is x is equals to x plus 1. So you can, instead of writing the whole big statement, you can just write x plus equals to 1, which means the same thing. And similarly, this x minus 1 is equals to x c. X minus equals to 1. These assignment operators are also known as shorthand operator or the augmented operators. You can write any of the arithmetic operator before the equal operator and equals to then any value, which will be expanded to the c. X equals to x into 2, like this. You can see this practically as well. I write n3 equals to n3 plus 9. Or I will write this n3 plus equals to 9. Now print n3. No, we have not given n3 any value. We will give n3 equals to 18, and we will comment these out first. And we'll execute this code. And here it's 18, and here n3 is equals to 18. 18 plus 9 is 27. Then again, n3 is not 27, so 27 plus 9 is 36. If we expand this line, it means n3 equals to n3 plus 9. Here n3 was 18, and now after this, n3 is now 27. And if we plus 27 and 9, we'll get 36, which is the output. Okay, I think this is clear. You can also perform the other operations like minus, subtraction, 18, or multiplication as well, 243, and a double exponentiation, that is C. So these operators, these are called the augmented operators, which we can use like as a shortcut to replace the whole, like the complete line. Instead, we can just use the shorthand operator. So now the next operator we have are the logical operators, and which it always like checks whether the condition is true or false and will return a single output. like AND operator. It will return true if like both on the left hand side and the right hand side values are true. If both the values are true, only then it will return the true. But if any of the side, like if LHS is false, it won't even check the other side. It will just directly return you the false output. Secondly, we have OR operator. It returns true if either of the side is true. Like if this side is true, it won't check the second side either if it's a false or not. It will directly return you the true. But if both the values, like if it checks this value is false and this value is also false, so only for that time it will return you the false output. And lastly, we have the NOT operator. It flips the output, like no, not the output, it flips the, yeah, the output, that is, it flips whatever, whether the output is true, it will invert into a false, and if it's a false, it will invert it into the true output. So if you check the precedence, if these all operators are used together any expression, always the NOT operator is executed first, then the AND operator, and lastly the OR operator. So first priority goes to the NOT operator, secondly AND operator, and third is OR operator. We will see this as well practically. And you generally use, sorry, A equals to 34. Generally you use these operators with the relation operator to check the condition, whether the condition is true or false. A is greater than 35 and A is less than 78. So we'll see this, which is a false. Why? Because A is smaller than 35 because A is 34, but its A is greater than 35, which is a false. But here this condition is true. But again, this one is false, so it won't even go to the other condition. It will directly will just return you false as an output. But if we will use OR here, it will return you the true. Why? Because this condition is true. Here, this one is false, so it will jump to the other condition, that is A is less than 78, and that condition is true. So here it will return you the true as an output. But what if we want to use the NOT operator? NOT operator don't use the, like, it don't work like AND and OR operator. Like it will just take one argument, NOT, and now we will have to write that A is greater than 35 and A, no, we'll see this much only for now, and it will return you true. Why? Because A is not greater than 35, which is a false as an output, and not will invert whatever the output is attained or whatever the output is obtained by the condition. So since that A is greater than 35 is a false, not will revert that output false into a true, and it will return you true as an output. And you can also use the AND operator here also. A is less than 78 again. But since this condition was false, and for the AND operator, we don't have to check both the condition. If first condition is false, the other it won't even check the other condition, because one of either of the condition is false, the output itself is a false. So now this condition gives the output as false, and that false is given to the NOT operator. NOT operator will revert that false as an output and will return true instead of false. Similarly, if here is OR operator, that means A is greater than 35, which is a false, but A is less than 78, which is a true. And OR operator will return true if either of the side is true. So now the true is given to the NOT gate. Sorry, the true is given to the NOT operator. So the true will be reverted back and the output will be false. See, here you got the output as false. So this is how the logical gate works. I hope this is understandable to you. We will now uh, move to the next topic, which is the bitwise operator, membership operator, identity, and precedence. We will see one by one. First of all, it is the bitwise operator. So, what are the bitwise operator and how do they perform the functions? Bitwise operator, we generally use this operator only for the bits value like 0 and 1. So, I told you, like 0 means the false and 1 means the true. If and bitwise is used, so which means 0 plus 1. Agar so the bitwise operator are somehow similar to the logical operators only, like for the logical and the bitwise AND. If any of the output for the logical operator, if any output is returning to the true, and another one is returning to the false. That is, true is 1 and false is 0. So if you use logical AND, it will return you what? It will return you 0. Similarly, if there is 0 and 1 with the bitwise AND in between, it will always return you to the 0. And for the OR, logical OR and bitwise OR also perform the similar operation, but the difference is only that the bitwise operators are used with the bit values like zeros and ones. We cannot use these operators on the other values, like numeric values. The numeric values we can use, but these values will first converted to their bitwise for like their bits format. Like we've converted the decimal to the binary data types, which so the data type which is converted like the binary, which you get after converting from decimal to binary. These bitwise operators are operated only on those kind of numbers, not on the not directly on the integer values. You know now that OR also. And what about the XOR? XOR is somehow similar to OR, but not exactly. Like the conditions for OR operator is that if any of the side is true, it will return the true. But also when both the sides are true, logical OR will return true on there also. But for the bitwise XOR, if any of the side is true, it will return true. But if both the sides are giving the true as an output, it will return as false. And for the both false also, it will return false. So for the XOR operator, we need to keep in mind that if any of the side is true, it will return true, but not the both. And if both the sides are false, it will return false there also. Then we have the bitwise shift. So what are the operational? What is the function of these shift bits? These are used to perform the mathematical operation in a very fast way. If you use the left shift, it will multiply your value with the 2 raised to the power n. And similarly, here the right shift, it will divide your value to the with the 2 raised to the power n. We will see this practically later. And then we have the membership operators. If we want to check whether a number or whether any value is there is sequences there are in Python, and if we want to check whether a value we have, if it's present in that sequence or not, we can use the membership operator. We will see what are the sequence in our upcoming videos, but for now it's only that. Like in the string, I will show you practically as well. But then first we will see the theory concepts, and then I'll show you all the operators one by one practically in the end. And then moving forward, we have this identity operator, which is is. It is same as equal operator, but we just use is in place of equal equal. It also checks the have is this identity operator, which which not only checks the value, it also checks whether the two variables, if they are pointing to a same or exact memory locations or not. It also returns output as a true and in false. If both the variables are pointing to a same memory location, it will return you the true, and if it's not, then it will return you the false. See, if two variables are the same object or not. It not only checks the values of the variable, like the equal equal operator, but it also checks the memory location, if the memory location is also the same or not. And lastly, we have the precedence. It's not any kind of operator. It's like the operators also have the precedence. Like when we use all these operators all together in any sort of expressions, so what are the operators which will get the higher priority and which will get the lowest priority? So in operator precedence, here we have the operator precedence. The first priority is always given to the parenthesis, that is the brackets. Then exponentiation, and then we have this multiplication, divide, row division, and modulo at the same priority level. Then we have plus and minus operator, and after that we have the comparison operators, then we have logical operators, and in the end we have the assignment operators. Assignment operators always have the least precedence. If we check in Python or in C or C++, everywhere the precedence is same. Here it's equal operator, that is the assignment or the shorthand operator, we can say. So this much for today. Now we will see all the things we have covered by now practically, and I'll show you some examples of on what places we can use the comparison operators, the logical operators, and the working of bitwise operators as well. So let's get started. N1 equals to 9, N2 equals to 18. And now that we have seen the working of arithmetic operators, we can now see the working of other operators as well. 23, 27, See, there N3, I have kept the numbers in a collection. This square brackets and whatever the value we have inside these square brackets, these are considered as a part of a list, and list is a sequence which we will study later. But for now, to see the implementation of some operators like membership operators, we will just check and like see the implementation only. First of all, if I'll print 2 in N3, then print 23 not in N3, print N1 is N2. We will write one more. N4 goes to again 9. Now print N1 is N4. See here, 2 is present in N3, 2 is not present in N3. It's 23, 67, and 89. Again, 23 is 23 present in N3, which is a true. But it's written it's not present in N3. Like is 23 is not in N3, which is a false. So here again we got the false. And N1 is N2, N1 is 9, and N2 is 18. So it is a false. Here N1 is 9 and N4 is also 9. So N1 is equals to N3, which is a true. Now you can also use that membership operators in string also, like oh, my name is Anushka, and we will see the N in here too. See, if there is any N in this string, it will return true. See, you can use these membership operators in any sequence. There are some type of sequence in Python like string, list, tuple, and dictionary, which we will study. And but for now, we know the strings, so you can use this membership operator on strings as well. Mm. Capital A in here. Mm. Capital R in here. Mm. And we will execute this and see here. N is present in str2, which is a true. Here, M is present in str2. See, here we have M, but a small m. But as we know, Python is case sensitive language. That means capital M means something else to it, and the small m means something else. So here we don't have capital M in our string, so it will return you a false. And then we will move to our bitwise operators. You can directly perform the bitwise operators on your integer, not directly, but uh, you can uh, you can just type your code with the integer. Your Python interpreter, it will first convert that code into the 2 raised to the power 18. So this is the this is what the output, that is that this is what the operation, the func or that the expression that this uh, left shift will evaluate, and then we have the right shift, which means it's the same, just the difference is here it's not the multiplication, it's the division instead. It would be 0. If we will write n2 on the, we will change the value of 18 here. We will write it 2, and then it means 2 raised to the power 2 here, 8. After dividing this, you will get the output as 8. It will give you the quotient only in the integer format and not the decimal one. So I've shown you the working of the bitwise operators as well. And now we will solve some basic questions which are most likely to be asked in the examinations about from those topics, that is the comparison operators and the logical operator. First of all, we will solve the question if an individual is eligible for voting or not. See, you will ask the user to enter their age, that is in input, and logical operators, the comparison operators. We will solve some expressions like for the your logical operators. If one, we will see this true or not true, print boolean. So what will this expression will return? See, I told you the precedence. Always OR gate will return true if any of the side is true. So we have true on the right side. So your final output, it will be a true. See, here it's true. And like the same, we can also do by applying the conditions instead of just directly writing true and false. Like 12 is greater than 19, or 91, I'm sorry, or 67 is not equals to 87, and not false always. Then again, we have or 12 is greater than 91, which is a false. So here it's false or false. We will see some questions about the operators that no that the arithmetic operators precedence. Uh, we will solve some expressions like 23 into 2 less if divide 2 and n1. You can solve these questions also by yourself. And now we will see 4 into 2 into 2 plus 6 friend and 2 and 3. Mm. So now here we'll see how these expressions will be evaluating. Uh, First of all, the highest precedence we have is of exponential function. So first of all, it will return 23, and raised to the power 2 means 23 into 23, and then plus, and then 56 divided by 2, it is 28, and then it will evaluate this expression and will add the 28 to it. Secondly, we have 4 into 2 into double asterisk 2, that means 2 raised to the power 2. Uh, this expression will be evaluated as 4 into 2 into 2, that is 2 into 2 is 4 plus 6. So here again, we will get 4 into 4, that is 16. plus 6, and it will not be like that 4 plus 6, that is 10 into 4, that is 40. It won't be the output will be 22. And here also, first of all, this double asterisk, it will get executed, that is 4, and 4 modulo 4, that means the remainder, actually, the remainder, it is equals to 1, and then it will evaluate as n3 equals to n3 plus 1. That is 2, because n3's value is 1. So let's see the output here. 55,557, and here it is 22, and here is 1, as I told you. So that's it for today. Oh, we will continue our classes. That's all for today's video. I hope you enjoyed whatever we covered in this class, and I hope you will practice and will learn whatever we discussed. And if you have any doubt regarding these concepts or whatever from the last video concept also, you can drop a comment. We will see and will respond to whatever you have a doubt. And till then, you can practice the questions. Like today, we discussed several new concepts, the very basics of the Python, and the most like are those very important topics. So, be in touch with them. And for the next video, we will be covering the sequences, that is the strings, and I will show you practically how we work with the strings and all. So till then, take care. Bye bye. See you in the next video.